Today we're going to take the trig functions from yesterday and introduce three more, which are called the reciprocal function and reciprocal functions. And each of the three trig functions, sine, cosine, tangent, has a reciprocal function. And the first one is called the cosecant, and the cosecant is 1 over sine of theta. So 1 over sine theta, which is the same thing as sine being flipped, so it would be the hypotenuse over the opposite side. The secant is 1 over 1 over cosine of theta, or cosine flip, so the hypotenuse over the adjacent. Now cotangent can be rewritten as 1 over tangent of theta. It can also be written as cosine over sine, because we know tangent is sine over cosine, so if I flip that becomes cosine theta over sine theta, and then if we relate it back to the triangle, it would be the adjacent over the opposite side. So again, sometimes it'd be easier to do 1 over tangent, sometimes it'd be easier to do cosine over sine, and other times it'll be easier to do the adjacent over opposite. So this example here, we're going to evaluate, if possible, the 6 trig functions of each angle. So 7 pi over 3. 7 pi over 3 belongs to the pi over 3 family. So the sine of 7 pi over 3, the cosine of 7 pi over 3, and the tangent of 7 pi over 3. So in the pi over 3 family, the sine is square root of 3 over 2. So square root of 3 over 2. The cosine is 1/2, and the tangent is going to be just the square root of 3. Now, 7 pi over 3, to figure out what quadrant that is in, that's bigger than a full circle, so if we subtract a full circle, 6 pi over 3, we get 1 pi over 3. So this angle, 7 pi over 3, will have all the same signs, S-I-G-N-S, like positive or negative, as pi over 3, which is in the first quadrant where everything is positive. So we have our sine, cosine, and tangent of 7 pi over 6. Now to figure out the secant or cosecant, secant, and cotangent, we can do a couple of things. So the cosecant goes with sine. I know that doesn't make a lot of sense. You would think cosine, cosecant go together. But I just remember it as the opposite of making sense. So the cosecant of that theta of 7 pi over 3, we can take the sine and flip it, 2 over the square root of 3. Well, we know we can't have the square root of 3 in the denominator, so we do multiply the top and bottom by the square root of 3 over 3. So then the cosecant of 7 pi over 3 becomes 2 times the square root of 3 over 3. Now the secant is just the cosine flipped. Well, 1 over 2 will flip to 2 over 1, which is just 2. And then the cotangent. The cotangent of 7 pi over 3 is equal to, again, we could do 1 over tangent. We could do cosine over sine. Either way will get you the answer. I'm going to deal with, just do 1 over tangent, because our tangent is just a single thing. So 1 over the square root of 3. Multiply the top and bottom by the square root of 3 over the square root of 3. So we get the square root of 3 over 3. Now you may look at that and say, wait a minute, isn't that the tangent of pi over 6, that family? Yes, it is. The cotangent of pi over 3 will be the same as the tangent of pi over 6. Cotangent and tangent are the only ones that work that way because, remember, cotangent is the adjacent over opposite, whereas tangent is opposite over the adjacent side. So that's why it just switches here. All right, now we look at 7 pi over 4. 7 pi over 4 is on our unit circle, so we don't need to add or subtract anything. So we'll do the sine of 7 pi over 4, the cosine of 7 pi over 4, and the tangent of 7 pi over 4. Now what's nice about the pi over 4 family is we have the square root of it, that the x and y coordinate, the sine and cosine, are both the square root of 2 over 2. Square root of 2 over 2, and the tangent is 1. Now 7 pi over 4 is in quadrant number 4, where the sine value is negative, which makes our tangent negative. All right, so then we can do the cosecant of 7 pi over 4. Well, that's going to be sine flipped. So negative 2 over the square root of 2, multiply the top and bottom by the square root of 2 over 2. That will give us negative 2 square root of 2 over 2. The 2's will cancel and we're left with negative square root of 2. Now because we have the same values here for the sine and cosine, the cosecant and secant are going to be the same. So we could write it all out, but we know it will simplify to the square root of 2, and since cosine is positive, secant will be positive as well. And then cotangent of 7 pi over 4 is going to be 1 over tangent, so just negative 1. All right, now that our angle is negative 3 pi over 2, I'm going to add a circle, so plus 4 pi over 2. That's 1 pi over 2. So we'll have our sine of negative 3 pi over 2, cosine of negative 3 pi over 2, tangent of negative 3 pi over 2. Sine of pi over 2 is 1. The cosine of negative 3 pi over 2, which again is the same as pi over 2, is 0. And our tangent, remember, tangent is sine over cosine. 1 over 0 is undefined. Now we go and write the cosecant of negative 3 pi over 2. That is going to be 1 over 1, so just 1. The secant of negative 3 pi over 2 is going to be 1 over cosine, or 1 over 0, which is undefined. And now cotangent, you may be saying, well, how can I do an undefined? How can I flip that? Well, we can, flip our tangent here. So our cotangent of negative 3 pi over 2 is going to be 0 over 1, which is 0. 0. Then our last one for this example, negative 4 pi over 3. Again, I'm going to add 6 pi over 3 to make it a positive angle that's on the unit circle. That just, again, helps me. You don't have to do that. So then we have the sine of negative 4 pi over 3, the cosine of negative 4 pi over 3, and the tangent of negative 4 pi over 3. Equals. Well, 2 pi over 3 is in quadrant 2, where cosine is negative. So when we get there, we'll just make our cosine negative. The pi over 3 family has a sine value of the square root of 3 over 2, which means the cosine is going to be 1/2, but negative because we are in quadrant number 2. And then our tangent, we are pi over 3 family, so our tangent is going to be the square root of 3, but it's going to be negative because we are in that family. We are in that quadrant, I'm sorry. So we did a pi over 3 family up here. So we have our cosecant, our secant, and cotangent values. We just have to adjust the signs for quadrant number 2 as opposed to quadrant number 1. So the cosecant of negative 4 pi over 3, that is going to equal, we had up there 2 square root of 3 over 3, then the secant of negative 4 pi over 3 is going to be negative 2, because we are in quadrant 2, and then the cotangent of negative 4 pi over 3 is going to be negative square root of 3 over 3. Because again, I just used these values here and adjusted them based on the sign. So now example number 3, it says evaluate the trig function using the period as an aid. So I'm just asking for the sine value of these right here. I'm not asking for anything else, cosine, cosecant, or anything. So sine of negative 8 pi over 3, again, we can add circles, but we know it's going to be a pi over 3 family, so we know it's going to be the square root of 3 over 2, either positive or negative. So if we can figure out where this is, okay, so negative 2 pi over 3, and the nice thing is you could stop as soon as you realize what quadrant you're in. You may be able to look at that and say, well, I know I'll be in quadrant number 3 if I have negative 2 pi over 3, but if not, add another 2 pi, and then you get 4 pi over 3. So that means, again, we are in quadrant number 3, so my sine value is negative square root of 3 over 2. And then with letter B, 9 pi over 4, if we take 9 pi over 4 and minus 8 pi over 4, that's going to be 1 pi over 4. And since it's a pi over 4, we know it's a square root of 2 over 2. And since we're in quadrant number 1, it is positive. So that is your answer. So you're starting to see that we're using coterminal angles a lot by adding or subtracting a circle, in that we really need to have those families memorized. You know, what are the sine, cosine, tangent of all of our pi over 3 family, our pi over 4 family, our pi over 6 family. The pi over 2 family you can probably figure out easily enough without having to memorize it. So thanks for watching the video. Make sure to like it and subscribe.